All right, can you hear me? Yeah?
Yeah.
Okay. So this talk is about Apache Beam. Maybe some of you know Google Dataflow. So Beam is a donation inside the Apache Software Foundation from Dataflow. So who I am, I'm software architect at Talend. So maybe you know Talend, I hope you know Talend. I'm also a member of the Apache team inside Talend. So it means that we are working directly on the Apache project used inside the Talend product. And I'm member of the Apache Software Foundation, and I'm working more or less on 20 Apache projects. So Beam is one of these Apache projects, but I also, around big data, I'm working on Falcon, Apache Lens, Group Insider, and middleware, Scala, complex things. So, what is Apache Beam? So Apache Beam is an acoustic programming model. So let's say you have your application running on big data, so you implemented your different job using MapReduce, and you say, okay, now I would like to use Spark. You have to redo the job again and again. So maybe later you want to upgrade to Apache Flink instead of Spark. Again, you do the job. So it's very painful. It's a lot of effort. And so maybe you want something more generic. So you write the code only once, and the same code will run inside MapReduce, inside Spark, inside Flink, or whatever. That's the purpose of Beam, to be agnostic. Okay. The name Beam, do you know why we named Beam or not? Or any idea? No? Batch and streaming. Beam, batch and streaming. Okay? You come from there. So it means that using Beam, you will be able to implement both batching, but also streaming jobs.
You didn't want to call it Scratch?
I won't say all the names that we imagined, but Beam is the one that we took. So basically, different SDKs. So in Beam, you will see we have a programming model. I'm going to introduce to you the Beam programming model. And in addition of a model, we have some SDKs. So the SDKs is the way that we implement this programming model. Right now, we provide only one, is the Java SDK. But very soon, hopefully next week, we will have the Python SDK. And maybe later, probably in a couple of months, we will provide DSLs on top of the SDK. Okay. And right now, we have different runners ready to use. So the runners you will see is the translation of your Beam code inside the backend that you want to use. So the backend is your Spark cluster or your Flink cluster. So now we have a runner for Apache Flink, directly provided by the data artisan guy. The data artisan guy are the guys who make Flink. Okay, so it's directly committed by the Flink guys. We have an Apache Spark runner, thanks to Cloudera. Of course, we have a Google Cloud Dataflow runner, thanks to Google. And we have two coming. One is the local one. So the local one is you have a local JVM and you want to run your job inside this local JVM. You don't want to use a complete cluster, just want to run locally. For tests, for example. In the unit test is what we do. Okay? So you have the local runner, and very soon, this is my job, we will have the OIGI and Caravan runner. So it means that you will be able to deploy your Beam pipelines, your Beam job, inside a Caravan. Okay? So why Apache Beam? First thing is portable. The same code is used on different backends and different topologies. So it could be a local, it could be a cluster, it could be a large cluster, it could be Spark. It doesn't really matter. It's the same code. Okay. Unified. You use exactly the same function, whatever you are in batch or in stream. Okay. You will see that you can create your own function, what we name the PTransform, and this transform you can use in different pipelines, batch or stream. Advanced feature, I'm going to talk about windowing. So we'll say what a window is. So it means that in the SDK, in the model, we have some advanced feature allowing you to implement some, let's say, very advanced way of manipulating your data. The way that you manage the late variable of the data. The way that you manage the watermark, so grouping of the data, all this. It's directly in the SDK. And extensible, of course. You want to implement your own connection to different backends, maybe Cassandra, maybe JDBC, maybe Kafka, or whatever. Of course, in Beam, you are ready to use I/O, what we name the I/O. You want to create your own, you can. You want to create your own transformer, you can. You want to implement your own coder, depending on the data type that you want to manage, you can as well. So it's completely extensible. And of course, as all Apache projects, we love contribution. So if you have any ideas, or any new connector, or whatever, you can submit directly to the Apache project. So what is the Beam programming model? The first thing that you're going to do is to create pipelines. The pipelines start with one connection, so you retrieve the data from somewhere. You send what we name a PCollection, so you send the data, and you apply a set of transformation on this data. Okay, so basically you have an endpoint, whatever it is. It could be a file, it could be JDBC, it could be Kafka, topic, Kafka partition. You apply the first transform, which is basically I read from the input, and I create a PCollection. After that, I can transform this PCollection in another PCollection. So you can chain, you can have a lot of different steps in your pipeline, and at the end, you can create another. Okay, pretty easy. So the pipeline is the data processing job, is a graph. It's a graph of steps. I go from this step to this other step. Maybe some of you know Camel. Do you know Apache Camel? It's exactly the same. In Camel, we talk about route. In Beam, we talk about pipeline. Basically, it's the same concept. And what we transport inside the pipeline is a PCollection. So you know probably in Java what is a collection. Do you know why P? Parallel. No, parallel collection. It's like a collection, but you can manage this collection as a subset of collection that you spread into your cluster. So it's a parallel collection. I will give you some details about what is a PCollection. After that, you can use transform. Of course, you have transform provided by Beam itself, group by key, reduce by key, count. All these functions, these transform are provided by Beam. Or you can create your own using a composite transformation. You want to orchestrate different transformations. In that case, you will use a composite transformation. And we have one special kind of transformation, is the I/O transform. The fact that you read from somewhere or write to somewhere. Is a transform like another. It just depends on another system outside of your pipeline. So a PCollection. The first thing which is very important about PCollection is the fact that it is immutable. Once you have created your PCollection, it's not possible to remove or add new elements in the PCollection. Okay? So if I create a PCollection like this, it will stay like this in my pipeline execution. One PCollection is only local to one pipeline. It's not possible to share a PCollection through different pipelines. Each element of a PCollection has a timestamp. Do you have any idea why I need a timestamp to my PCollection element? Streaming. Exactly, for the streaming and especially for the grouping, so the windowing. To define a subset of data inside my PCollection, I have to use a key. Basically, the key is the timestamp. Okay. You can use a coder to manage different kinds of PCollection. For example, Evro, if you want to marshal or unmarshal using different serializer. You can use string, or you can use your own coder. Okay. One thing which is very important is we have two kinds of PCollection, in bounded or bounded. For batch is bounded. You know the number of data that you're going to read. or unbounded streaming. As soon as I have new data, I will extend my PCollection. For the unbounded PCollection, you can use windowing. So basically, I receive some data. I would like to group my data in a subset. So it's what we name the window. For the one that use Spark, it's exactly the same. In Spark, you have the notion of window. In Beam, you can decide fixed time window. You want to group the data every hour. All the data for this hour. So I will take the timestamp, and for the last hour, I will take my window. I can have sliding time window. So I would like to take all for 20 minutes, and when it's done, I take 20 minutes more. You can also have session window. In that case, it depends not on the time, it depends on the data. Okay, so you can trigger when your window is complete or not. Okay? It could be closed. Yeah.
How do you define a session?
A session?
Yes.
In terms of function, you mean? It's based on the data. So you will implement a function defining the session, and you will define the trigger that deals with the session. So, for example, the function could be, I would like any data with this key matching this regex. And all data matching this regex will be in this session. Okay? So it doesn't depend on the time, it depends on the data itself. Of course, to deal with time skew and data lag, we define different triggers. So you can have a trigger based on the time, based on the data, based on time and data, based on the predicate. It's up to you. Okay? So all is defined on the PCollection. The I/O. The I/O is, I would like to, let's say, I consume from Kafka. My pipeline, the starting point of my pipeline is a partition on Kafka. It's a transform, a special transform, but it's an I/O. In Beam, we have two kinds of I/O: the sources and the sinks. Okay, the sources I read from an external system and I create a PCollection. The sink, I take a PCollection and I flush into an external system. Okay? You have to support bounded or unbounded PCollection in your I/O. It depends on the I/O of your choice. I mean, Kafka, for instance, it could be bounded or unbounded. What could be bounded in Kafka? Do you have any idea for the one who knows Kafka? You know, in Kafka, when you consume, you define an offset. You define, I would like to consume all messages starting from this offset. But you can also specify the number of messages that you want to consume. So if I provide an offset and a number of messages, I will have a bounded PCollection. If I just specify the offset, I will have an unbounded PCollection. Okay? So it means that the same I/O, depending on this configuration, can be unbounded or bounded. Okay? We provide some I/O. File, of course, BigQuery, Bigtable, Ebro, Kafka, JMS, MQTT, CX, all this stuff. It's my daily job. You can have custom I/O, so it means that you can implement your own I/O. Okay? And of course, in the I/O, depending on your use case, you may want to deal with all the timestamp, the watermark, the deduplication, the parallelism of the I/O, so it could be tricky sometimes. But again, you should match your expectation in your use case. Don't say that you have to implement all of the watermark, all this stuff, but most of the time you will have to. The SDK. So this, what we saw is the programming model. Now I need an API to implement this programming model. I need an API to implement my pipelines. So the first one that you can use is the Java. You will implement your pipeline using Java. Very soon you will have Python. So you will implement, not in Java, in Python. You also use, very soon, Scala, Go, Ruby, Groovy, all these languages. Okay? What we are doing now. We're extending the SDK with new SDK. And you can imagine to create SDK on top of SDK. I mean, you will see that this one is very low level. And sometimes for end developers, you need something easier to use. It's what we name DSL. So instead of using directly the Java SDK, you will use the DSL on top of the Java SDK related to your domain. For example, at Cask, we can imagine that instead of using directly the Java SDK, they will create the Cask DSL. Specific to the application that they provide. Okay? So the DSL could be Java itself, but it could be in other languages. Why not describing a pipeline using XML or using JSON? Okay, just DSL on top of the API. This is an example of the Java SDK. I create a pipeline. Okay, so it's pretty easy. I define the first I/O, so I read from the file here. I apply a transformation. I just count the number of words, and I flush this result into a file. This is Beam language. This language, this code, will be translated by the runner depending on the target backend that you're going to use. So if you use the Spark runner, this code will be converted, translated as a Spark code. If you use the Flink runner, exactly the same code will run into Flink. The thing to understand is the runner itself does not provide the backend. The runner is just a translator to the backend. Okay? It means that you still need your Spark cluster cluster extra. Okay? So I define the pipeline and I just run the pipeline. This is an example of transformation. Okay, so instead of just reading, I would like to do an advanced transformation. This is an example of transformation with a window. So I use a window. I define the session window based on the duration. Okay, I would like to have a session of 2 minutes. And I trigger that when the watermark is raised, I trigger my date. Okay? This is an example of window, and this is an example of transformation. Pretty easy. Do you see some issue with this? Do you think it will run out of the box, whatever the runner will be? For you as an end user, it doesn't matter. But for us in the runner, sometimes some runners may not support some features. Okay? In MapReduce, it's not so easy to implement something like this. In Spark, of course it is. Or Flink, it's pretty easy. So sometimes it's the challenge of Beam is to be able to exactly the same code work the same way, whatever the runner will be. That's the tricky part of Beam. So the runner translates the code into your backend. Okay? So you have different runners for Apache project. Most of the time, I think you're going to use your runner provided, but you can also create your own runner. In Beam, we have an API to implement your runner. It's pretty easy. Easy to understand, not easy to do. Okay, the API is pretty easy. The implementation to be tricky. So right now we have a Google Cloud Dataflow runner, we have an Apache Flink, the Apache Spark runner, and other runners already available. The local one is already available. The original is in progress. Sorry? Not yet. If you want to work on it, it's not planned for now. Yeah, honestly, in terms of scope, you could be cool to have it, but it's not yet planned. If you want to contribute,
what's the cost? What's the overhead time compared to the native? I don't know on Google Cloud or let's say native Spark with Scala. What's the cost?
Nothing, because actually the runner does not translate the code. He executes directly the code. So it's not a compilation, it's just a translation. So it means that for you at the end, it will be exactly the same. Yeah, that's why we use the runner instead of code generation or whatever. At the beginning in Dataflow, we evaluated the code generation. But actually, this costs a lot, because you can have different behaviors, and depending on the version, let's say, of Spark that you're going to use, the code that you generate is not maybe the one that exactly in the same version of the Spark version that you use on your cluster. With a runner, you have a translation, so it's not the code generation. That's the key difference. Some use cases, quickly. You can take a look on the data flow example. You have real use cases. The thing which is very important to understand is the fact that you can do both batch and streaming. Maybe some of you know Apache Crunch. You know Apache Crunch? If you take a look on Apache Crunch, it's exactly the same in terms of programming model as Beam. The reason is the guy who created Apache Crunch worked at Google on Dataflow. But Crunch is only batch. You cannot do streaming with Crunch. That's the key difference with Beam. Beam, you use exactly the same layer to do both batch and streaming. You don't, in Crunch, you have only bounded collection. In Beam, you have unbounded and bounded. That's the key difference. Okay? So you can implement ETL, ELT, catch-up processing, daily aggregation, basically whatever you want to implement. Okay? Very soon we will extend with messaging. So again, instead of manipulating only data, very soon you will be able to manipulate message. For example, a Beam pipeline will be able to start with a REST service. It will expose a REST service. And so it will receive some JSON request directly. So you will be able to process message more than data. It's a mix between Apache kernel and Apache Beam. It's a merge of the two technologies. You saw that I'm coming from middleware, so I bring my middleware backend into big data. That's the purpose.
So you're planning to support Apache Storm?
Yes.
Okay.
Yes. It's already on the way.
Awesome.
So quickly, just to show you some example of real code. The gaming. So let's say you play, I don't know, you play soccer, you play whatever you want, and you have, or tennis, let's say tennis. So you have player, team, score, and time. This is what I have on my cluster. On HDFS, I have a file containing the name of the player, the name of the team, the score, and the timestamp when this score has been created. What I would like to do is to create a user score to have the sum of all score for one player, and I would have to have this score per hour. Okay? This is the first user score pipeline. So I create a pipeline, I read from my input. The first thing that I do is I pass my event. So it's a CSV file containing player, team, score, timestamp. So the first thing that I have to do is to convert each row in this file into an object that I'm gonna manipulate into my pipeline. This is the purpose of this first transform. The second thing is I would like to summarize, to sum all score for one user. Okay? And after that, I send to a big query table. So this is the pipeline. The two things that I have to extend is this and this, because I use custom transformation. To use this, I use an Avro serializer. So I create an object containing user, team, score, timestamp, and I just use my coder, which is an Avro coder. It's directly provided by Beam. So I just create this class. Nothing more than that. It's enough. And now I can create my function to parse the CSV file. So on this, you can see that this class extends the do function. So the do function is provided by Beam. And the only method that I have to override is the process element. So for each element, which is again user, comma, team, player, comma, team, comma, score, team, timestamp, I extract each part and I create my game action info, which is my Avro an annotated class. It's done. After that, I have a PCollection. Okay? The second thing is, I implement a PTransform that takes a PCollection of game action info, so the one that I created in my previous step in the pipeline, and creating another PCollection, which is a string integer. Player score, string integer. And the only thing that I do here is to take the PCollection and just apply some provided transformation, Beam provided transformation. And it's done. My pipeline works like this. I go back there. This is provided by Beam. So it will read directly from the file system. The file system could be HDFS, could be a local file system, whatever you want. He called my parsing event, the one that I showed you before. He extracts using my composite transformation, and the PCollection created will be on BitFrame. It's done. This code will run, for instance, in Spark. Okay. If I show you another pipeline, the early score pipeline is exactly the same, but I add a window to group my PCollection per hour. So it's what I'm doing now. Exactly the same startup, the same I/O. I read from the file. Exactly the same transform. I pass my event. Okay, it doesn't change. Now I show you here how to filter some data. So in the PCollection, I would like to remove some part of the data. I would like to filter the data. You can use filter.by predicate. It's provided by Beam. Okay. For example, you want to remove all row in your PCollection. It's not removed, it's in your. Okay. It's not removed from a PCollection, but it's not processed by the pipeline. And all the timestamp greater than a mean value or lower than a mean value and greater than the max value. Okay, you want to know, for example, the score from this morning 6 a.m. And once it's done, so I do the filtering, and here I do my fixed time window. So exactly the same. I define this is my timestamp. So the timestamp are stored into my game action info. You remember, player, score, timestamp. Okay? So I have a timestamp. And I apply my fixed window time, so here you can see that by default, I will take a window of 1 hour, 60 minutes. And it's done. This window will create my block of all PCollection for an hour window. Okay? And after that, I write each window to my BigQuery table. Okay? Some point about the roadmap. So the project entered into the incubator, the Apache incubator, February 1st. Okay? It was a bit challenging because there are a lot of dependency to Google Cloud Platform, so we have a bunch of cleanup to do, etc., etc. So basically, the code has been really donated inside the Apache Foundation, 25th of February. Okay? And so now we are in the refactoring, cleanup, polishing, runner API, extension of the I/O, the new DSL, all this stuff. So it means that mid this year, it could be a mess. Now it could be a bit chaos because we expect a lot of contributions. So it means that we have to maintain both the refactoring plus the contribution. So it could be a bit challenging. So basically, late this year, we will have the stable version of the project, so the one who will release. And our target is to be end of this year as a top-level project. So we give up to the end of this year as an incubator, doing the refactoring, accepting contribution, extending the API and the SDKs. and end of this year top-level project. And at this point, it means that the Google itself will switch from Dataflow to Beam. End of this year. If you want to be involved in Beam, and I hope so, you can take a look on the Apache Beam website. You can take a look on the Jira, the mail list. You can also clone the Git repo and take a look on by yourself. And if you have any question and answer, I'm here for you. Yes?
When will you support that? Yeah, data pipeline via that?
Say that again, data pipeline?
Via that, directed acyclic graph, right? So if I have a desire to combine multiple inputs and generate multiple outputs, right? Right now you support, it's a one-to-one matching, right? What if I want a back, multiple outputs?
So you mean, for example, you want to split your PCollection in multiple PCollection and to create different outputs depending on the PCollection?
Yes, and also potentially multiple inputs, right?
Okay.
For example, yeah, one side is real-time gaming, right? Casino gaming data. The other side is some limited, small amount of demographics information, right? I combine these three data
Okay,
sets.
I see.
I want to do some analysis, and then I split the output to say,
yeah.
these are the ones I'm interested in, these are the ones to discard.
Okay, so the easy part is I receive a bunch of PCollection or a large PCollection, and you want to split in different PCollection to send to the backend. This is already possible. Okay, you can already do that. What you said is I have multiple let's say input, and I would like to manage. Right now, to do this, you have to use a store. I mean, you have to read you have to create the first pipeline, reading from the first input, creating a staging output, and another pipeline starting from this one. What we plan to do is to add what we name enterprise integration patterns. So it means that EIPs. So it means that what you described will be possible, because the pipeline will be able to send to another pipeline. So we will have a special I/O where you can output from one pipeline, and this output will be the input of another pipeline, but it's not yet done. Right now you have to use a local HDFS or something like that to share between your pipelines. Yes?
How much do you know when the Scala SDK?
Mid of this year is planned for summer 2016. We started, but it's not yet ready. So mid of this year. In Scala, normally it could be, we will provide two versions of Scala 2.9 and 2.10. We are working on both. And you will have some DSL on top of Scala as well. But the SDK itself in Scala will be mid of this year. Yes?
Do you know if any of the big names Cloudera are planning to implement that? Because I think Crunch is supported by Cloudera. I'm sure.
Crunch is not inactive.
Yeah,
it's mostly there.
Okay.
Cloudera already work on Beam.
Okay.
Okay.
Yeah, like
Tom White is working with us on this. Do they include this in CDP, CDH?
Yeah.
I don't know.
Okay.
I don't know. The same for all. I don't know. It's, if Beam, and I think it will be the case, if Beam become more and more popular, they will have to embed it into the distribution. But now I don't know. Other questions? No? Yes?
How many contributors are in the project?
15 from Google, 2 from PayPal, 3 from Data Artisan, 1 from Cloudera, and 1 from Talend. So roughly 20-25. And I was with Google yesterday. In Google, there are one team dedicated to Beam. So their daily job is to work with me. No other questions?
Okay.
Thank you.
Thank you.